we're going to talk about 3 different types of spectra that can be produced when light interacts with matter. There are continuous spectra, which look like a rainbow spectrum where all the colors blend together. There are emission spectra, which look like just bright lines on a dark background. And then finally there is something called an absorption spectrum or absorption line spectrum. Sometimes it's called a dark line absorption spectrum, and this is where it looks like there's a continuous background, but certain colors have been removed, and so you'll see dark lines in the spectrum. Let's talk about how each of these are produced. In physics, the principles that govern how different types of spectra are produced are called Kirchhoff's laws. And one of these says that when the atoms inside a hot, dense object are excited or energized, they give off light of all the different colors and make a continuous spectrum. And so it looks like a rainbow with all the colors blended together. So hot, dense sources give off continuous spectra. For example, the tungsten filaments inside an incandescent light bulb are hot and dense, and thus they give off continuous spectra. The interiors of stars are hot and dense, and they give off continuous spectra. To produce an emission spectrum, then what we have to produce an emission spectrum, what has to occur is that the atoms inside a hot, low-density cloud of material or gas has to be energized. And in that case, only specific colors are going to be produced, thus making an emission line spectrum which consists of certain colors, certain lines, and we have a black background. It looks like this. And so we have a hot, low-density cloud of gas. For example, that could be a nebula in space. Well, that's only going to produce the specific colors that the atoms in that cloud are sensitive to. What's happening at the atomic scale is that electrons in those atoms in the cloud of gas have been energized, and then they're dropping down levels and emitting photons of light. Individual atoms may be able to emit more than one color of light, but they're not going to produce an entire continuous spectrum. And so what we'll see is an emission line spectrum like we have here on the right. It looks like bright colored lines on a dark background. Finally, if we take the light that's produced from a continuous source and then pass it through a lower density and cooler temperature cloud of material or cloud of gas, and we look at the light that emerges, the spectrum will be an absorption line spectrum. It looks like this. Let's say that we start with the continuous light coming from a hot, dense source. We pass it through a lower density and cooler collection of atoms. Those atoms will absorb the colors that they are sensitive to. It's not going to be every color, just some of them. And so on the other side, if we take the emerging light and pass it through a prism or a spectrograph, what we'll see is what appears to be a continuous background with certain colors removed, an absorption line spectrum. At the atomic level, what's happening is that when all of that light, essentially white light, passes through the cloud of gas, the atoms in that cloud of gas absorb certain colors of light that those atoms are sensitive to. They'll only absorb certain colors because they only have specific electron energy transitions that the electrons are able to perform. They can't do every single color, and so you'll only get certain colors absorbed. All the others pass through that cloud of gas, and so in the end, what you get is that absorption line spectrum. It turns out that stars always have absorption line spectrums, and that's because even though the interior of a star is very hot and dense, as you go to the surface of the star, the interior is surrounded by lower density, cooler material. And so the continuous light that's produced inside of a star has to filter up through the outer layers of the star, and thus the emerging light from a star is an absorption line spectrum of light.